Hello friends, very good morning. In today's video, we are going to study about the projection of a pentagonal pyramid which is resting on one of the slant edges on HP. Friends, you know very well, a pentagonal pyramid will have 5 slant edges, and whenever it has to rest on one of the slant edges, one of the corner of the base of the 5 corner, one should come to the right side of the observer. So placing the object on HP, obtain the top and front views of the solid when one of the corners of the base is to the right side of the observer. So friends, here I am going to construct a pentagon of the given side of 30 millimeter and obtain the top and front view. So friends, here this is the pentagon I have got. It has got a side of 30 mm, and we will name the corners as A, B, C, D and E. We will obtain the base in the front view, that is by projecting lines from here. You get this as A dash, B dash. This is C dash, E dash, and this point is D dash. Now I should get the vertex in the top view, that is obtained by bisecting any two adjacent sides of this pentagon. So this is O I get here. So I join O to A, O to B, O to C, O to E and O to D. So these 5 slant edges we have got, and this is O, the vertex. Friends, the height of the object is given to be 60 mm. So I obtain the center of the base by projecting lines from here. This is our O1 dash. From there, I write a vertical line, the axis having length is equal to 60 mm. So I just mark 60 mm. The 60 mm is the height of the solid, and this is O dash, the vertex, that is the tip of the pyramid. Let me join this O dash to all the corners of the base, like O dash A dash, O dash B dash, O dash C dash, O dash E dash and O dash D dash. This is how the pyramid looks in the front view when it is resting on its base A, B, C, D, E on HP. And in the front view, friends, this line will represent this O dash D dash, one of this slant edge. One of this slant edge. He says it has to be on one of its slant edges on HP. So friends, I am going to redraw this figure 1 as figure number 2 by drawing this triangle with O dash D dash on HP. So this is going to be D dash, and we are going to get this figure. How to get it? D dash is here. This will become A dash B dash, and this is O dash. The front view. C and D are closer to this D. Measure this and take the distance as C and E, C dash, E dash. The axis to be shown, that is O dash, O1 dash. Friends, now the object, the pentagonal pyramid, is resting on O dash D dash, one of the slant edges on HP. I'll write down here O dash D dash means the slant edge is on HP. Now friends, let us see how does it look in the top view. Friends, when it's resting on slant edge like this, the complete base of the solid, that is A dash, B dash, C dash, E dash, D dash, is visible in the top view. So this is applicable for any of the pyramids, either resting on slant edge on HP or triangular face on HP. The complete base is visible in the top view. So friends, I am going to get all these 5 corners of the base like this. So to get AB, draw a vertical line from this A dash, B dash. a horizontal line from here. The point of intersection of vertical drawn through A dash and the horizontal through A will give you point A. Similarly, you will get point B here. Obviously, this AB will be 30 mm. Then we have got D here, vertical from D, horizontal from D. The point of intersection will give you D. Then you have got C and E, vertical from C, horizontal from C. The point of intersection will give you this point C. This is AB, this is C, and this is D. You have to obtain the point E, vertical line from E and the horizontal from here. The point where those two intersect is the point E. This is C, opposite to C is E. You get it here. Friends, we have got all the 5 corners, and since it is visible to the observer in the top view, we will join them by straight line. So I join A to B, B to C, C to D, D to E, A to E. So this is how the base looks in the top view when you view from the top. Let's obtain this vertex. So draw a vertical line from O dash, a horizontal line from here. The point of intersection of these two will give you O. Now we have to join this vertex O to all the corners. So I will join O to A, O to B. You can see here, friends, OA and OB can be seen from the top view. That's why shown by full line. Then O to E, the border is also full line. O to E is also visible. And then we have got O to C, that is also visible. So we have got all the 4 we have got. We have to get this D. Friends, when you have this pyramid resting on one of the slant edges, the edge on which it is resting on HP is not visible in the top view because the body is opaque. So I have to show this OD, the slant edge, by a dotted line or an invisible line. Friends, this is how the pyramid looks in the top view, and you can find here this is O1, we have to mark O1. The slant edge OD on which it is resting on HP is parallel to VP, parallel to VP. But it says in the question, it has to be at an angle of 30 degrees to VP. So friends, I have to redraw this figure such that OD which is parallel to VP will just get inclined at an angle of 30 degrees to VP. This 30 degrees to VP can be seen only in the top view. Hence friends, I am going to redraw this figure as it is with OD at an angle of 30 degrees to VP. So friends, I will just write a line here. This line is at an angle of 30 degrees to VP. On that I am going to mark this, all these base, slant edges, etc. So let's first of all mark OD, O and D. We know the length of this OD. So I'll this mark as O and this point as D, OD. The length of OD is equal to this. From D, you move this distance, this much of distance, obtain the value of C and E, the position of C and E. So friends, I'll write a line here, and this CE I'm going to obtain. This is C and E. So you can take this as C and this as E. C we have got. And again I should get AB at this distance from corner. That will be obviously 30 there. So to measure this distance and mark AB. So AB will be 30 mm. So this is A and B. So this point is A, this point is B, this is C, D, E. And finally O is here, friend. The figure whatever we are getting here should be a photocopy of this. So friends, I will join this to the corners like this. C to D, D to E, B to E, A to E, then O to A, O to B, O to C, and O to E. And friends, here, as usual, this VD is going, OD was going to be a dotted line. So these two figures are exactly identical. This figure is exactly identical with this. Friends, the slanted OD is at 30 degrees to VP as per the question, to VP. Friends, this is the final top view you have got. Let me obtain the final front view of this solid. So friends, let's go in order. A and B. So draw a horizontal line through A dash B dash on which AB will lie. So draw a vertical line through a horizontal line through this. They intersect at this point. We call it as A dash. Similarly, B dash is also on the same line. Draw a vertical line from here, a horizontal line from here. The point where they intersect is our point B dash. Then C and E lie here. So we'll write a horizontal line through this. So C and E. Draw a vertical line from here. The point of intersection of vertical drawn through A and the horizontal through the C, will give you the point C dash. Then we have got the point E. So E is here. Draw a vertical line through E, a horizontal line through this. So this E will lie somewhere here. This is how E will lie. So A, B, C, this is E. D. Draw a vertical line through D. Horizontal. D is on XY. So horizontal line through this. Vertical line through this point. The point of intersection will give you that. So this is A, B, C you have got D, and friends, you have to join all these by straight line. So I will join A to B, B to C, C to E, C to D, and this E to D and A to B. Friends, this is how the base of the solid looks in the front view. Let us obtain the vertex O, a horizontal line through O dash, a vertical line through this. The point where those two intersect is the vertex O dash. Finally, friends, all these corners to be joined to this vertex. So I join O dash to A dash, O dash to E dash, O dash to D dash. Now I have to join O dash to B dash and O dash to C dash. Now what happens when you are joining O dash to B dash? It is intersecting this line. So whenever two lines intersect, and if one of them is already a full line, the connecting line or the intersecting line should be a dotted line. So friends, I am going to show this by a dotted line since it is not visible. Similarly, C, when you are joining C to O dash, it is intersecting this line ED, and hence I am going to show this line O dash C dash by a dotted line. Friends, this is how the object looks in the front view completely, and these two figures will give you the complete projections of the solid. So friends, you can observe here in this final view, if you observe, the object, the pyramid is resting on OD or O dash D dash. O dash D dash is one of the slant edges, and that slant edge is at an angle of 30 degrees to VP, and also the two triangular faces containing that OD or O dash D dash are equally inclined H. We can observe triangle DEO and CDO. They make equal inclination with HP. This is what they have given. So the final views are satisfying all the requirements of the question, and hence the solution is correct. Friends, if you like this video, do share with your friends. Have a wonderful day.